Okay, so looking at the 2021 maths mock paper, we're moving on to section B. And question 7 is saying that a section of water ducting system used to divert floodwater is in the shape of a prism as shown. All units are in meters. And it's first asking us to calculate the internal volume of the duct. So if we go to our log tables, we'll see here that a solid of uniform cross-section, or a prism, the volume can be given by AH, where A is the area of the base, and obviously H is the height. So using that, we can see here that the base of the prism is a triangle shape. And as we know, the area of a triangle is given by a half by the base by the height. So then using the measurements we were given in the question, we get a half by 5, which is the base here, and then the height is going to be 2. So these two will cancel out, so that's going to be 5. Therefore, the volume of the entire thing is going to be the area of the base, which we just found is 5, multiplied by the height, which is 8, as given in the question. So therefore, the volume is simply 40 meters cubed. Make sure to include your units of measurement. Okay, now the next part says, write an equation to represent the volume of water in the duct at any time t in terms of h and w. So as we found before in the previous question, the volume of the prism is going to be given by the area of the face multiplied by the height. So if we were to simplify that down, we'd say a half by w by h by 8. And then simplifying that further, it gives us simply 4wh meters cubed. Fairly simple. Now moving on to part C. It says that using similar triangles, show that w is equal to 2.5h meters. So if we were to draw out the two triangles that we have, over here we have the bigger area volume of the entire duct and then the smaller volume of just the water. So on the bigger one, we know that this is 5 and that this is 2. On the smaller one, we're saying this is W and this is H. So we know that in similar triangles, the ratio of all the measurements will be the same. So because they're in the same ratio, we can take the two measurements of the similar sides and divide them by each other. So W divided by 5, and because they're the same ratio, they will be equal, and it's equal to H over 2. So multiplying that across, the 2 comes up here, and the 5 comes up here. And we're wanting to find W, so we simply divide across by 2. And then 5 divided by 2 is going to give us 2.5h meters. So the next part says, show that the volume of water in the tank can be expressed as V is equal to 10h squared. So if we go back to part B, we found an equation for the volume in terms of W and H, which was 4WH. So we're going to write that down here, V is equal to 4WH. And we just found in part C that W is equal to 2.5H. So we can rewrite it again as 4 times 2.5H multiplied by H. Then multiplying it out, 4 by 2.5 gives us 10, and H by H gives us H squared. Okay, and then part E, it says, if the water is flowing into the duct at a constant rate of 3 meters cubed per second, at what rate is the height of the water changing when the water has a height of 1.1 meters? Okay, so first we're going to identify what we're looking for. We are first looking for the rate that the height is changing with regards to time. So that can be written as dH dt. And we don't know what that's equal to. And now what we know the volume of the water is changing at a rate of 3 meters cubed per second. So that's dV dt is equal to 3. So now we need to form an equation using what we want to know and what we already know. So we want to know dH over dt. and we know dv over dt. So now we want to multiply it by something that will cancel out to give us dh dt. So for that to happen, we need dh to be here on the top, and we need the dv to cancel out, so the dv here is going to be on the bottom. So we need to find dh dv. And we just found in the previous question that v is equal to 10h squared. So then if we were to differentiate that, we would find dv dh, which would be 20h. And now we want dh dv, which means we can simply invert it, which will give us 1 over 20h. So now moving back over here, dh dt is equal to dv dt, which we found was 3, all multiplied by 1 over 20h, and the h that we're given in the question is 1.1. Multiplying that all out, it gives us 3 over 20 by 1.1. If we go over to the calculator, we can see that that gives us 3 over 22, or 0.136 meters. And because it's a rate of change, it's going to be meters per second. Okay, now part F, it's asking us to show that the surface area of the water at any given time is given by A is equal to 20h. So, because the surface area of the water is simply a rectangle, we know that the area is going to be the width multiplied by what we are given in the question as the length, which was 8. And now we know from part C that W is equal to 2.5h. So we can again put that in, 2.5h multiplied by 8. And once you multiply that out, 2.5 multiplied by 8 is 20h meters cubed. And so once you multiply that out, 2.5 by 8 is 20h meters squared. And now on to part G. It says, at what rate is the surface area of the water changing when the water has a height of 1.2 meters? Okay, so this is another rates of change question. So we're going to take the same steps again of writing out what we want to know and what we already know, and then forming an equation. So we want to know at what rate the surface area of water is changing with respect to time. So that's going to be dA over dt. And now we already know from part E that dH dt is 3 multiplied by 1 over 20h. So dH dt is equal to 3 over 20h. Okay, so now we know that we want to find dA dt, and we know dH dt. So therefore, to make things cancel, the dH here is going to have to be at the bottom, and we need a dA on top. Okay, so we had just found that A was equal to 20h. So if you wanted to differentiate that, that would be dA dH, which would be equal to simply 20. So then we can come back over here and say that dA dt is equal to dH dt, which we know is 3 over 20 multiplied by h, and the h we were given in the question is 1.2, all multiplied by 20. So these two 20s here will cancel out, giving us dA dt is equal to 3 over 1.2. Putting that into the calculator, will give us dA dt is equal to 2.5 meters squared per second. And that's question 7, all done.